In the offshore oil and gas industry, the extraction, storage, and transportation of hydrocarbons often require specialized infrastructure, especially in remote or deep water locations where pipelines are not feasible. Floating production, storage, and offloading (FPSO) units have become vital assets in such environments, offering a versatile and efficient solution for oil and gas production. What is an FPSO? An FPSO, or Floating Production, Storage, and Offloading Unit, is a type of floating vessel designed to process and store oil and gas extracted from offshore fields. FPSOs serve as mobile production facilities that eliminate the need for fixed infrastructure, making them highly advantageous in deep water and remote locations where pipeline construction is costly or impractical. At its core, an FPSO is equipped with three main capabilities. Production. FPSOs have onboard facilities for processing hydrocarbons extracted from nearby subsea wells. These facilities separate crude oil, natural gas, and water, treating each product to meet specifications for storage, reinjection, or offloading. Storage. Processed oil is stored in large tanks within the FPSO's hull. The storage capacity of an FPSO varies, but most units can store substantial amounts of oil, sometimes up to several million barrels, allowing production to continue without frequent offloading interruptions. Offloading. FPSOs are designed to offload stored oil onto shuttle tankers that transport it to shore or to other storage facilities. Offloading operations typically occur through flexible hoses, allowing the vessel to continue production even as oil is transported away. FPSOs are unique in that they can either be converted from existing oil tankers or purpose-built for specific operational needs. This versatility gives them a significant advantage, as they can be deployed to different locations throughout their operational lifespan. Typically, FPSOs are anchored to the seafloor using a variety of mooring systems, such as spread mooring or turret mooring, which allow them to rotate with the ocean currents while remaining fixed in place. Components and structure of an FPSO. FPSOs are highly engineered vessels equipped with specialized systems and components that enable them to perform the complex tasks of offshore oil and gas production, storage, and offloading. The main components and structural elements of an FPSO include 1. Hull and storage tanks. The hull of an FPSO is similar to that of a large tanker, providing buoyancy and housing multiple storage tanks for processed oil. These storage tanks vary in size, but most FPSOs can hold between 500,000 and 2 million barrels of oil, depending on the design and requirements of the field. The hull also includes ballast tanks to maintain stability, especially during variable weather conditions. 2. Production facilities. FPSOs are equipped with production modules that handle the separation and processing of oil, gas, and water extracted from the reservoir. Key components in the production facilities include separators, gas compressors, water treatment units, and oil processing units. The production facilities treat the hydrocarbons to meet specifications for storage and transport, while water is typically treated and discharged or re-injected into the reservoir. 3. Offloading system. The offloading system enables FPSOs to transfer stored oil to shuttle tankers or pipelines. This system usually includes a set of export hoses, loading arms, and pumps that connect to offloading tankers. Offloading can occur at the stern or side of the vessel, depending on the design and prevailing sea conditions. 4. Mooring systems. FPSOs are anchored to the seafloor with mooring systems that keep them stable and in position over the reservoir. There are two main types of mooring: turret mooring and spread mooring. Turret mooring. A turret mooring system allows the FPSO to rotate 360 degrees to align with changing sea conditions, reducing strain on the mooring lines and enhancing stability. Spread mooring. This system uses multiple anchor points and is suitable for calmer waters, as it does not permit the vessel to rotate. The choice of mooring system depends on the water depth, environmental conditions, and field requirements. 5. Riser systems. The riser system consists of flexible pipes that transport oil, gas, and water from the seabed to the FPSO. These risers connect to subsea wells and deliver hydrocarbons to the production facilities on the vessel. Depending on the field's requirements, risers can be steel catenary risers, flexible risers, or hybrid riser systems. 6. Safety and environmental control systems. FPSOs are equipped with advanced safety systems to manage fire, explosion, and spill risks. Common safety features include firefighting systems, explosion-proof equipment, and gas detection systems. Environmental control measures such as oil spill containment systems and treatment facilities for produced water ensure compliance with environmental regulations. 7. Power generation and utilities. An onboard power generation system provides electricity for all FPSO operations, including production, processing, and living quarters. FPSOs often rely on gas turbines or diesel engines using gas produced on site when available. Additional utilities include water desalination, heating and cooling systems to support both the operational and living spaces on the vessel. 8. Living quarters and helideck. Most FPSOs are equipped with living quarters for the crew, including sleeping quarters, kitchen, medical facilities, and recreational areas. A helideck enables crew changes and emergency evacuations, especially for FPSOs located far from shore. How an FPSO operates. FPSOs are designed to efficiently handle the extraction, processing, storage, and offloading of hydrocarbons from offshore reservoirs. Their operations are highly integrated to ensure continuous production in remote and deep water locations. The key operational steps of an FPSO include 1. Extraction of hydrocarbons. The process begins with the extraction of hydrocarbons, oil, gas, and water from subsea wells located on the ocean floor. Flexible risers, connected to the FPSO's mooring system, transport the hydrocarbons from the subsea wells up to the production facilities on the vessel. Depending on the reservoir's depth and field conditions, the risers may be steel, flexible, or hybrid to ensure durability and stability under varying sea conditions. 2. Production and processing. Once hydrocarbons reach the FPSO, they are directed to the production facilities for processing. The production process involves several stages to separate and treat oil, gas, and water. Separation. Using separators, the mixture is divided into oil, gas, and water. High-pressure separators separate large volumes efficiently, while lower-pressure separators handle finer separation as needed. Gas processing. Gas extracted during separation can be flared, re-injected into the reservoir, or processed and used as fuel for the FPSO's power generation needs. Water treatment. Water separated from the oil and gas is treated to meet environmental standards before being either re-injected into the reservoir or discharged back into the ocean. The treated oil is then directed to storage tanks within the hull, where it can be stored until it is offloaded. 3. Storage of oil. The FPSO's hull serves as a large storage facility for the processed oil. Storage capacity varies depending on the design and the specific needs of the field, with most FPSOs capable of storing hundreds of thousands to millions of barrels of oil. This storage capacity is critical, allowing the FPSO to continue production without interruption, even when offloading cannot take place immediately due to adverse weather conditions or other factors. 4. Offloading process. When storage tanks are nearing capacity, the FPSO initiates an offloading process to transfer oil to a shuttle tanker, which then transports it to onshore refineries or storage facilities. Offloading is conducted using flexible hoses connected from the FPSO to the shuttle tanker. In some cases, FPSOs may use loading arms or export hoses attached to the stern or side of the vessel. Offloading operations require precise coordination between the FPSO and the shuttle tanker to ensure safety, especially in dynamic offshore environments. 5. Power generation and utilities. FPSOs generate their own power using gas turbines or diesel generators, which are often fueled by the gas extracted from the production process. This onboard power system supports all operations, including production, processing, and living facilities for the crew. Additional utility systems handle water desalination, heating, cooling, and waste management, ensuring smooth and sustainable operation. 6. Safety and environmental protocols. Safety and environmental protection are fundamental aspects of FPSO operation, given the potential hazards associated with offshore production. Fire and gas detection systems, emergency shutdown, ESD systems, and firefighting equipment are strategically installed to manage and control any emergencies. Environmental control measures, such as oil spill prevention and produced water treatment, are essential to minimize the environmental footprint of the FPSO. 7. Maintenance and inspections. To ensure operational reliability, FPSOs undergo regular maintenance and inspections. These activities can be carried out while the FPSO is operational to minimize downtime.